Welcome back students to the next set of reasoning questions. We've been doing reasoning questions of alkenes. Now let's see the next set, because whenever you're doing organic, not only the name reactions, not only the preparations, most important are the reasoning questions. So let's read the question and see what are the keywords we need to write in the question. Right. So why do isomeric branch chain isomers have relatively low boiling point as compared to corresponding straight chain? Okay, so they've given us three important things. One is they said isomeric branch chain, then they said corresponding straight chain, then they said low boiling point. These three things I need to concentrate and write the answer. So what examples are given? And they're given me two things. One is isopentane and one is neopentane. What is isomeric? Iso means similar, mer means unit. Fine. Now when I take this, how many carbons are there in this count? 1, 2, 3, 4, 5. Done. Here 1, 2, 3, 4, 1, 2, 3, 4, 5. Both are having 5 carbon atoms, so isomeric. But what is the difference? They are differing in the arrangement of the methyl groups. That means in one it is a straight chain with one single branch. Here it is completely branched. Now when we observe the boiling point, here for the branched chain, the boiling point is very less, means compared to that it is 282.5. Here it is 300.9. This is what they're asking us. They're asking us, why do isomeric branch chain isomers have relatively low boiling point as compared to corresponding straight chain or one branch chain at the center. Now let us write. So whenever I see, so you need to start your answer explaining about this. What are you observing? Here in branch chain, what is happening to the surface area? Here, see here, they're arranged like this, one after the other. Whenever you have to boil them, you need to break this bond, this, and gradually you need to break each and every bond. But here what happened? All the molecules are arranged in a spherical form, isn't it? So let's start writing that. In neopentane, what is this? This is a branched chain. What happened? You should tell me. Yes, simple thing. In a neopentane isomeric branch chain, first important thing, surface area decreases. When the surface area decreases, what will happen to the shape of the molecule? Yes, shape of the molecule or shape of this particular thing, shape of the molecule becomes spherical. Done. When the shape of the molecule becomes spherical, what will happen to the magnitude of London dispersion forces? That magnitude also will go down. Magnitude means measure, right? So magnitude of, I'm writing in short form, London dispersion forces or the van der Waals forces, that also will go down. So here surface area is getting less, shape of the molecule becoming spherical, magnitude of forces also, here means it is strongly packed, forces also decreasing. So once it is attaining a compact structure, it will tightly fit in the crystal lattice. Yes, when they tightly fit, let us write that also. Tightly fits in crystal lattice. These are the 4 key points which you should write. Surface area, shape, magnitude, tightly fits. This gives you a complete analysis of the whole concept. So because of these reasons, hence the boiling point is low. That's it. If you write this and underline, you will get complete mark in such questions. So this is how you're going to write this question. Let's come back into one more reasoning question. Now let's come back and do 2 more reasoning questions here. Both are of the similar type. Let's read. What do they give us? Why does CH18, that is, it has a melting point of 216.2, have higher melting point than C3HA, that is 85.3. Okay, it is almost 3 times, isn't it? Fine. So why is it like that? Why do C8H18 has higher melting point? Always remember, whenever they give you a boiling point question, a melting point question, your concentration should directly go into the branching concept, right? So let's recollect again. Always higher the branching, more is the boiling point. That's the first important thing you should remember. Let us write that clue there. What is that? Higher branching means higher BP. This is for the boiling point. When I have to speak about melting point, Same thing almost. What is that? Basically, whenever a molecule is compact in nature, right? Once again, I'm coming in the other way. What is compact? It is very closely packed. When it is closely packed, what will happen? Yes, the intermolecular forces of attraction are very, very high, very compact. Means I need to melt the whole molecule, break that molecule, open it up, and then only melt, isn't it? So in this case, when I see C8H18, so what is that in this particular thing? Now that we are comparing between C8H18 and we are comparing between C3 and H8. So in C8H18, we see it is 216.2. Let us write that 216.2. Now here it is 85.3. What is more in this? When I see the molecule, now in the molecule, the compact nature or the close packing of that molecule is very much more. Here it is C3H8 only. It is like this: 1, 2, 3 hydrogens, 3, 2 and 3. It is like the straight chain, no branching. But here when it comes to C8H18, there's branching in the molecule. Point number 1. An important thing is, you should remember, very close and compact packing. Compact means very close in nature, very means less space in between them. Compact packing of crystal lattice So what will happen because of this? Melting point will be high. Boiling point, listen. So melting point will be very high compared to C3H8. Simple, isn't it? So whenever you're writing that, speak in terms of compact packing or close packing, so that you can easily write the answer end of your answer. Here in this case, what is this? In isomeric alkenes, that is N-pentane, isopentane, neopentane, we have seen the earlier question in terms of boiling point. Now when I see the melting point, see here N-pentane, it is 143 Kelvin, straight chain. Isopentane a bit branched, that is 113 Kelvin. When it is neopentane, it is 256.4. The same reason, isn't it? As a molecule or the branching increases, very close packing increases. When the close packing increases, compact packing of crystal also is there. When the compact packing of crystal is there, obviously the melting point will be low. I need a lot of melting point to break those bonds and melt them. Yes, so you can write the same reason for both the questions. Now one more question based on your melting point of view. Let's see what is this. So here they've given based on melting point. Let's see the question and analyze how to write it in the exam. What do they give me? Among odd and even number of carbon containing alkanes, okay, which has lesser melting point and why? So here they've given me two things. One is they said you need to compare between odd and even number of carbon atom containing alkanes. So I need to take an alkane which is odd in nature and one more which is even in nature, right? Suppose if I take an example like, yeah, let us take N, okay, N hexane and N-heptane. Okay, let us take this example. This is a very common example, so I picked up. So what is N? Normal chain. So let's write. So I'm writing in the bond line structure, which I've already taught you how to draw bond line structure. Start from here. Hexane means 6, isn't it? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done. Here heptane means 7, isn't it? Now start drawing. 1, 2, 3, 4, 5, 6, 7. Let's count. 1, 2, 3, 4, 5, 6, 7. Done. Hexane means 6 carbon chain and heptane means 7 carbon chain. Now what is important? I should see which is odd and even. This is 6 carbon. It is even in nature. Here 7 carbon atom, it is odd in nature. Now they want us to compare between odd and even. Simple. Whenever they have, you have a concept of melting point. Remember one important thing. Boiling point means more of branching, more of boiling point. Point number 1. When it is melting point, very closely or compact packed this one high melting point. Once again, more of branching, more of boiling point. Compact packing or close packing, more of melting point. Remember. Now they said between odd and even. Now see which is compact packing, which is compact packing. This one is even, means evenly, one after the other, second after the other, second after the other, everything will get packed. But here in this case, odd electron, after the sixth one, this will again be branching. Okay, this will again be branching, and that will not fit into the crystal lattice. Yes, so important thing, here it is even and it fits in the crystal lattice. Let us write here, it fits into crystal lattice. When it fits in the crystal lattice, what will happen? Yes, magnitude also increases, the forces of attraction also increases, and here melting point will be high, because you need to break the lattice and separate that. But when it comes to N-heptene, I said it is an odd electron, and does it fit perfectly into the crystal lattice? Yes, it will not fit. So let us write that sentence also, does not fit perfectly into crystal lattice. When it does not fit perfectly into the crystal lattice, should I use more melting point? Not required, isn't it? So melting point, what I require will be less. Done? Let's try that. So does not fit perfectly into crystal lattice, so melting point is, or it will be lesser. So that's it. Which is having melting point? Lesser is this. Now let's write the order. Odd alkanes will have less melting point than even alkanes, because of this is the reason. Right. Now let's see one more question based on your solubility. Till now we have seen question based on boiling point and melting point. Let's read this. Are hydrocarbons soluble in water? Simple. So hydrocarbons, I know they are alkanes and alkynes. So when does this concept of how do we write the answer for solubility? Whenever you are speaking about solubility, we think or we tend to memorize, okay, polar solvent, non-polar solvent. That is it. So what is that thing? We've always studied like dissolves like. That means polar solvent like dissolves like. Means polar solvent will, if it is a polar solvent, it will be dissolved in polar universal solvent, that is water. If it is a non-polar solvent, nature is non-polar, then it will dissolve in non-polar solvents like carbon tetrachloride, acetone, kerosene, like that. Done. So what in hydrocarbons, what is the concept? When I take this hydrocarbon, so let us write that in hydrocarbon. Let us take one example, any example. Now let us take, this is hydrocarbon chain. Okay, here you have hydrogens. Now what is this? When does this molecule dissolve? When it breaks up into ions, isn't it? When does that break up into ions? When you have a difference in electronegativity. Done. When I take the electronegativity of carbon, it is 2.55. Here for hydrogen it is 2.2. Now when there is no electronegativity difference, the drag or the pull of those particular atoms will reduce, isn't it? So the difference is very less. If the difference is more, it would try to drag the electrons towards it and create a positive negative charge, and this will become a positive charge. Whichever is dragging will become a negative charge, whichever is losing will become positive. Means deficient. So here in this case the difference is very less. That's the first most important. Electronegativity, En means electronegativity difference is very less. When the electronegativity difference is very less, does it exist as poles, positive and negative? No, isn't it? Yes. So since let us say, since electronegativity difference is very less, what will happen? The molecule or the hydrocarbon molecule, whatever is there, I've just taken an example, whatever is there, it exists as non-polar. If it has electronegativity difference more, it will exist as polar molecule. That means two poles, negative pole and positive pole. Due to this concept, they or hydrocarbons exist as non-polar molecule. So when hydrocarbon exists as non-polar molecule, what will happen? Just now I said polar solvents will dissolve in polar molecules will dissolve in polar solvents. Non-polar molecule will dissolve in non-polar solvents. Simple, isn't it? Done. Now we have already come to a conclusion. It is non-polar solvent or non-polar molecule. So they are insoluble in water, and are soluble in non-polar solvents. Like, what are they? Just now I said carbon tetrachloride, acetone, what do you say, kerosene, diesel, benzene. Okay, this is your answer. So your teacher expects you to write this word, underline this word, then you can write hence or hydrocarbons exist as non-polar, underline this word, and you can underline this word, put it in inverted commas like this, and this also in a box. Right. So the next topic in different types of masses is equivalent mass. So basically equivalent mass, first I've written the definition so that when I start solving all this you will understand. So how is it defined? It is defined as number of parts by weight of a substance. Okay, we'll be taking a ratio of the number of parts of the weight of the particular substance, whichever element is given to you, that combines with or it displays directly or indirectly. Okay, so remember all these keywords in your brain, so it's easy when I apply in any all of these you will understand. Fine. Directly or indirectly means when they combine they're going to displace how much by weight, that is 1.008 weight of hydrogen, that is, or 8 parts by weight of oxygen, or 35.5 parts weight of chlorine. Okay, why did they give only specifically hydrogen, oxygen, chlorine? Basically the different methods for determining equivalent mass. What is that? Everything has a separate formula. 1, 2, 3, 4, 5, 6, 7, 8, 9 methods are there for determining equivalent mass. So for your prescribed NCERT syllabus, you have only general methods. What are those? We will see. So the first method is hydrogen displacement method. So this definition is common for this one, hydrogen, because I said it's going to directly or indirectly displace 1.008 parts of hydrogen. Right. Next, oxide formation method. Okay. Chloride formation method, I've taken this chloride displacing. I'll be comparing it in both. Next, metal displacement method. Next would be double decomposition method. I'll also be teaching you what is electrolytic method for calculating equivalent weight, neutralization method, silver salt method, as well as the last method is general method. Under this, as I said, you're going to study about calculating equivalent weight or equivalent weight of a metal. That is a general method which you have. Second, equivalent weight of an acid. Next, equivalent weight of a base. Next, equivalent weight of a salt. Right, all these you have for your syllabus. So the last one is compulsory, you should know, but that apart from that all these methods also come under equivalent weight. We'll be learning one after the other. Right, let us come back and do the 7th question. Right, hope the concept is clear. I'm doing it very slowly. Right. So question number 7, what did they give us? An organic compound with molecular formula C9H10O forms 2,4-DNP derivative. Right, reduces tolerance reagent, one more clue, and undergoes Canizares reaction. Done. On vigorous oxidation, it gives me benzene 1,2-dicarboxylic acid. Okay, identify the compound. They have given me benzene 1,2-dicarboxylic acid. So basically, whenever something is given, I told you, write the summary of facts. They said an organic compound with molecular formula C9H10O. Let us write C9H10O. 9H10O. Right? This forms 2,4-DNP derivative. Okay, and reduces tolerance reagent and undergoes Canizares reaction. So basically, C9H10O, what is the formula? How does it? How can I analyze whether it is aldehyde or ketone? They said it forms 2,4-DNP derivative. What forms 2,4-DNP derivative? Basically aldehydes. Which reduces tolerance reagent? Aldehydes. And which undergoes Canizares reaction? Compulsory, it is an aldehyde. So let us write the aldehyde which is there. So from this formula, separate out the aldehyde. So CHO. First let me take CHO. And how many are left? 1 carbon is over already. We still have 7 carbons. Yes or no? But whether should I write the straight chain or the aromatic thing? How will I know? They have given here one more clue. On vigorous oxidation, it gives benzene 1,2-dicarboxylic acid, they said. That means already there is benzene in the given product. That means the reactant also should have benzene. Correct? So this is your now C6H5CHO. Still we need how many? 6 are there? 7, 8, 9. That means there is an alkyl group here. But what is alkyl group? Total should be 9. 6, 7, 8, 9, 2 carbons. How many hydrogens are over? C6H5, 6, 7, 8, 9 means it should be basically C2H5. Then let us count 5, 4 is 5 plus 1, 4 here, 9, 9 plus 1, 10. So this is the C5H10O. This is the compound. Now this said, now see here, there is an aldehyde which undergoes a complex with 2,4 derivative, done. It reduces tolerance reagent, done. It undergoes Canizares reaction, done. They said this on vigorous oxidation. Vigorous oxidation. What does it do? It forms benzene 1,2-dicarboxylic acid. Same compound, very easy way. It forms benzene 1,2-dicarboxylic acid. Over. Now identify the compound. So let us recall again once again. They said this compound, it indicates aldehyde because it is, we have seen these 3 conditions. It forms 2,4-DNP, aldehydes form 2,4-DNP derivative, it reduces tolerance reagent, it undergoes Canizares reaction, that's why. And they also have given me positions 1, 2. Means they said 1,2-dicarboxylic acid. That's why I picked up 1 and 2. The formula I have written this, and finally I have written the product. Remember that alkyl group, whatever is present on the benzene ring, this alkyl group, always it is oxidized to COOH. Whatever may be the length of this particular alkyl group, let the alkyl group be C3, C4, whatever it is, it will get compulsory, it gets oxidized to COH, because aldehydes on oxidation, aldehydes on oxidation gives acids, but this also, irrespective of the length, I am writing that, irrespective of the length of alkyl group, what does it get? It gets oxidized to COOH, whatever is the length. So this is how you are going to solve. I'll meet you again with the 8th question. Now let us come back and start off solving the 8th question, right? Now let's read the question. I told you, as soon as the paragraph based question is given to you, you need to write the summary of facts. Then only you will understand what to do, what are the things, because everything will be clear. So summary of facts, right? What do they give me? They said an organic compound A having the formula C3H8O, molecular formula C3H8O, C3H8O on treatment with copper at 573 Kelvin gives B. Then they said B does not reduce filling solution but gives an LOPPT of compound C with I2 and NOH. Okay, that means an iodoform reaction. I2 and NOH is iodoform reaction. Which will show iodoform reaction? Basically methyl ketones only of the compound C. Okay, deduce the structures of A, B, C. Done. First of all, I have to write the summary of facts. What did they give me? They said C3H8O, which is A. This was treated with copper. Which temperature? 573 Kelvin. What does it do? Copper, basically, it oxidation. What did it give? It has given a compound B. Did they give us the formula of B? They nothing. But they said B on treatment, it does not reduce filling solution but gives an LOPPT with C, with I2. So iodoform reaction, NaOH, it has given a compound. What is this? This is an iodoform reaction. So it forms compound C. Correct? Which is an LOPPT, they said. Now, start analyzing the question. I know I have written the summary of facts. I have to analyze the question now. See how to analyze the question. They said compound B does not reduce filling solution but gives an LOPPT of C with iodoform. That is I2 and NaOH, iodoform reaction. That means compulsory compound B should have a methyl ketone. Compulsory it should have a methyl ketone. So this formula is given. Write first methyl ketone and C. I am writing compound C, methyl ketone, C double bond O. This is C, methyl ketone. Now in this formula already it is C3H8O. How many are over here? 2 are over. Correct? 2 are over. So how many are left? 2 carbons means there is only 1 carbon here. C3H8. See here 1, 2, 3. H8 means C3 are over. C3 plus 3, 6. But this is B we said. This is a methyl ketone because it undergoes further iodoform reaction. Now go back. This was treated with copper 573 Kelvin oxidation. Which on oxidation gives ketones? We very well know. Primary alcohols on oxidation gives aldehydes. Secondary alcohols on oxidation gives ketones. Come back. What is the formula they've given? A formula they've given is C3H8O. So secondary alcohol, because secondary alcohols only give ketones. Now write the secondary alcohol with the same number of carbon atoms. C3, CH, CH3, OH. Secondary alcohol. Now this compound was treated with iodine and sodium hydroxide. So what is this? This is an iodoform reaction. What has it given? It has given me an LOPPT. Right? Now basically this copper, what is it doing? It is reduced. Basically this is not an oxidation process, this is a reduced process. Copper will reduce, isn't it? The reaction is reduced by copper, but secondary alcohol. So this should be what? Not oxidation, this should be reduced. Sorry students, reduction or reduction. Right. Now this compound, whatever is there, it undergoes or it forms an LOPPT. What is LOPPT due to? It is due to the formation of iodoform CHI3. This is iodoform. What is the compound? This is an LOPPT. LOPPT. What is this? This is compound C. And along with this, the leftover, this comes as CHI3 and the leftover comes as sodium salt of carboxylic acid. Isn't it? Now this is how you have analyzed. So you will be writing compound A is C3H8O. Compound B is methyl ketone, C double bond O CH3. Compound C is iodoform, which forms an LOPPT. Right, so how did I get this? Let us reanalyze the question. I took one clue. I have written the summary of chart. I took one clue. This is an iodoform reaction, means it should be methyl ketone. We very well know copper, it helps in reduction. So which one? Secondary alcohols on reduction, correct? Gives me ketones. That's done. So with this clue, I have completed the 8th question. Let me come back and do the 9th question. So let's come back and start off with the 9th question, students. Let's see this. What do they give us? As I told you, whenever paragraph based question is given to you, try to write summary of facts. Right. So what do they give me? An organic compound A which has characteristic odor or treatment with sodium hydroxide forms two compounds B and C. Okay, there is a compound A, organic compound A, it seems. When it was treated with a compound, a characteristic, it was treated with sodium hydroxide. It has given me two. What was that? Compound B and compound C. Now compound B has a molecular formula C7H8O. So they said it has C7H8O as a molecular formula. Which an oxidation with CrO3, an oxidizing agent. What had happened? It gives back compound A. So this was allowed to undergo oxidation with CrO3, that is an oxidizing agent, oxidation. It has given compound A back. Then they said compound C is a sodium salt of acid. They said compound C is what? It is sodium salt of acid. Salt of acid. This when heated with soda lime. C was heated with what? Soda lime. Soda lime. It was heated. Heat. Yields an aromatic compound D. It has given D. It is an aromatic compound. So one more clue is given to me. Aromatic hydrocarbon. Okay. Aromatic hydrocarbon. So I have to deduce A, B, C, D and E. C, D. Done? Right. So let me start off how to write with the formula. First of all, I have to see whether there is any clue given to me. They said an organic compound A, no formula. I can't do it. Compound B, there is one formula. And they said C is sodium salt. Here this is a formula. Here I can start off. So the compound B is formed by reaction with A, reaction of A with sodium hydroxide. So sodium hydroxide means when we say concentrated solution of that. Basically concentrated solution of an alkali means a base, sodium hydroxide solution. Where we use it? We use it in Canizares reaction. Canizares reaction, what does it form? It forms both, and sodium salt means salt of that a particular acid and an alcohol. In Canizares, what will happen? Basically, there is a disproportionation reaction. Same compound undergoes oxidation and one more forms sodium salt of that. Yes or no? Yes. That is one clue which I have got. So, what is A now? A is aldehyde. And one more thing, this particular A is an aldehyde. Which one? What is that? Which doesn't have alpha hydrogen. That is the most important. Canizares reaction is shown by aldehyde which does not have alpha hydrogen. Right? Fine. So, a little bit clue I have got here. One more thing is, they said reaction C, it treated with soda lime, they said, and gives me aromatic hydrocarbon. So aromatic hydrocarbon means C should be sodium salt of carboxylic acid. Means basically I told you in Canizares reaction, one will be your sodium salt of carboxylic acid and one more will be an alcohol. Yes or no? Because this doesn't have alpha hydrogen. Yes. Understood, students? Now C also, we said it is treated with soda lime, that is sodium hydroxide and calcium oxide. It is an aromatic hydrocarbon. They said that means a benzene ring. Let us start off. Now analysis is over. I have to start. They said compound B, the formula is C7H8O. This is the formula which they have given me. I told you along with this is also formed one more compound, that is sodium salt of acid. right? So now basically I told you from where do we have got it from sodium hydroxide. What is the formula? C7. That means compulsory there is a presence of a benzene ring. Here also there is a presence of benzene ring, but one was sodium salt of carboxylic acid, which is compound C, and here C7H8O. In Canizares reaction, which one will be alcohol and one will be sodium salt. How did I write this? See here, C6H5. Now this is 6, this plus 7. H5 is here, 5, and this 6, 7, 8 over. Now what should be this compound? Compulsory we know. Canizares reaction is shown by aldehydes which doesn't have alpha hydrogen. So benzaldehyde is in this one. So benzaldehyde does not have alpha hydrogen, isn't it? There is no, because aldehyde is directly linked. If there is one more group CH2, then it is alpha hydrogen adjacent to CHO. So benzaldehyde is a compound. So benzaldehyde, this is your Canizares reaction where it forms an alcohol and sodium salt, corresponding sodium salt of that. Now see what was it done? It was treated with soda lime, NaOHCO, and it has formed an aromatic acid, aromatic hydrocarbon. So what does it do? Na2CO3 is out, isn't it? Minus Na2CO3 comes out. What is left? You are left with aromatic hydrocarbon. Aromatic hydrocarbon. They said B is treated with CrO3. What is this? Oxidizing agent. It will help in undergoing oxidation. Now let us see whether this is right. We very well know alcohols on oxidation gives aldehydes. So this is right, isn't it? Alcohols on oxidation gives aldehydes. This also proves. So always remember, students, simple. Whenever a question is given to you, try to make summary of facts and then finally try to analyze. Pick one clue and start doing it. So let's meet again with the 10th question.